Let's take a look now at the process of calculating coverage rates adjusted by population size. Calculating a weighted average is more precise than a non-weighted crude measure. This calculation takes into account that not all supervision areas are the same size. The contribution each supervision area makes to the calculation of the average coverage should be related to its size. Although a weighted average is more accurate than a crude measure, in most cases it is only slightly more precise. Data can be weighted by supervision area population sizes using the direct adjustment method. While weighting is not needed when making LQAS judgments of a supervision area, it can be used when aggregating data to calculate coverage for the entire program areas. As you can see in this table, from our initial example of assessing the percentage of deliveries attended by a clinically trained provider, we have 5 supervision areas, but in addition of listing the respective sample sizes and the respective number of correct responses for the indicator being assessed, we have the population size per supervision area. In column number 4, we first calculate a mini coverage proportion for each supervision area. And these values are coming from dividing the number of correct responses over the respective population, the sample size. In column 5, we present the population size per supervision area, while column number 6 is a weight which is calculated as the population in each supervision area is divided by the total population of all the supervision areas in the entire program area. So this particular value of 0.245 is a result of dividing 10,718 over the total population of 43,707. And we do the same for the rest of the other weights in supervision areas B, C, D, and E. Column number 7 is the final calculation, which multiplies the weight and the mini coverage proportion in each supervision area. Adding these numbers together in the last column gives the overall coverage rate for the entire program area. In this case, the weighted coverage takes the value of 43.5%. So it is this way that we calculate weighted coverage rates for an entire program area based on population size in each supervision area. And for this particular example, we can say that the coverage in the entire program area is 43.5%. Let's take a look now at how we calculate confidence intervals for weighted coverage rates. Based on the same previous example of addressing the percentage of deliveries attended by a clinically trained provider, we have information per supervision area. Column number 2 is the same mini coverage proportion called P calculated per supervision area. Column 3 uses the value of Q, which is a result of 1 minus P. Column 4 shows the result of multiplying P times Q. So for this particular first value of 0.244, this is the result of multiplying 0.579 times 0.421. Column 5 once again shows the population size per supervision area, and column 6 shows the population weight per supervision area as we did it in the previous table. So once again, this particular weight of 0.245 is a result of dividing 10,718 over 43,707. The last column, number 7, presents the calculation of the square of the weight per supervision area multiplied by P times Q and then divided by the sample size N per supervision area. This procedure results in a very small values that have more than 3 decimal places. That's why some of the values shown in the table are 0. The actual values of these very small decimals are located in the 4th decimal place, which is not shown. When they are added together, they result in a value of 0.002. The final step is to multiply the square root of 0.002 by 1.96. The resulting value equals plus or minus 0.088, and this is the confidence interval. Therefore, the coverage in the entire program area for this particular example is 43.5% plus and minus 8.8%. In other words, we are 95% confident true coverage in this program area is between 34.7% and 52.3%. For calculating weighted coverage rates and confidence intervals for more indicators, you can make use of simple computer programs like Excel, where you can include these calculations and plug the numbers to obtain weighted coverage rates and their associated 95% confidence interval. Let's take a look now at a table that shows results from a baseline and one survey done during year 1 using LQAS for our particular indicator. How do we use this data to make decisions? Let's assume that we are at the beginning of year 2 and that we have results from baseline and results from a recent LQAS survey conducted at the end of year 1, assessing deliveries that are attended by clinically trained providers. From the results summarized in this table, we have annual targets for this particular indicator and a decision rule for year 1. We also have the average for year 1 as well as a decision rule for this particular average. Now, for each supervision area, we have the number of correct responses for this particular indicator being assessed. And for the results that we have from the most recent LQAS survey carried out in year 1, we can conclude that supervision area D and E are classified with the highest priority. Why? Simply because we can see that the correct number of responses in each of these supervision areas, that is 5 in supervision area D and 5 in supervision area E, are below the decision rule for the average coverage, which is 6, but they are also below the decision rule for the target, which is 7. We can also conclude that supervision areas A and B are performing quite well and should not be our priority in terms of changing interventions. And in fact, we should learn from these supervision areas and to the extent possible apply those conditions from supervision areas A and B into supervision areas C, D, and E, as these 3 supervision areas are not performing as expected, particularly supervision area D and E, which are below the average and below the target. With this information, managers can make informed decisions as to how limited resources can be allocated towards improvement and towards meeting established targets during the life of the project. The table shown in this slide was introduced in the previous lecture, and it gives you guidelines as to how to classify supervision areas based on results obtained at the local level, whether performance is below the average and whether performance is below target. If a supervision area is below the target and below the average, this supervision area is going to be classified with the highest priority, and managers will need to make some tactical decisions towards improving the performance of this supervision area for the indicator being assessed. On the other hand, if a supervision area is below the target but not below the average, it will be classified with our second highest priority. Likewise, if a supervision area is not below the target, but it is below the average, this supervision area will be classified with our second highest priority. Finally, if a supervision area is not below a target and is not below average, then this supervision area should not be classified as a priority, and the intervention in this supervision area should most likely continue as is. In the next lecture, we will concentrate more on how to analyze results at the local level following this table for classifying supervision areas for monitoring purposes and to make tactical changes based on this analysis.